Okay guys, we are going to look at multiplying matrices, and this is a review from Algebra 2. And I know some of you have already told me that you didn't like it, but hopefully the second time around it's better. Okay, when you multiply matrices, the one thing that you have to remember in order to multiply matrices, when you have your two matrices, you always have row by column. When you multiply two matrices, so you have this matrix 1, row by column, and then this matrix, row by column, these two middle numbers, right here, the column of the first one and the row of the second have to match. So for example, if I have a 3 by 2 matrix, that means the number of columns in this matrix is 2. The second matrix I use has to be a 2 by something. I'm going to make it a 2 by 3. Because both this column in the first one and the row in the second match, we can multiply. And when we multiply, we're going to end up with a 3 by 3 matrix. Okay? And I know you kind of remember that from last year. And for this reason, because this column and this row right here have to match, have to be the same dimension, multiplication is not commutative. Okay, you can't switch which matrix is first in the expression whenever you want, because it'll give you a different answer. So let's look at a couple examples. I'm going to start with this matrix. 4, 1, 2, 0, negative 6, negative 3. This has 1, 2, 3 rows, 2 columns, so it's a 3 by 2. And I'm going to multiply that by the matrix negative 1, 4, 6, 0, 3, 5. This one, 2 rows, 1, 2, 3 columns, so it's a 2 by 3. So it looks kind of like that example I started up there. These match, so I'm going to end up with a 3 by 3 matrix. Now we have to talk about how we multiply matrices. You always take row by column, and then you add those parts that you need to. So what we're going to do is, I know I'm going to get a 3 by 3 matrix, so I'm going to draw a big matrix here. I'm going to start with my first row, because it's row by column. So the rows of the first matrix, columns of the second matrix. So I have 4 and 1. So I'm going to take this row, 4 and 1, times this column. So I'm going to take 4 times negative 1, plus, I have another term there, 1 times 0. So it's basically like you take this, and kind of flip it around to match these. So times 4 times 1. So 1 times, so plus 1 times 0. So that's my first term, first row, first column right there. Okay, now, if I keep going across, so there's my first element. I'm going to have 3 elements here because it's a 3 by 3. To get my next one, I take this same row times this column. So I get 4 times 4 plus 1 times 3. And you can go through and add those here in a second. Now to get the last one, same row, 4, 1. Now I have to multiply it by the last column, 6, 5. So the 4 goes with the 6, plus the 1's going to go with the 5. Okay? Now, to get, like we said, this is a 3 by 3, so this is going to have 3 rows with 3 columns. So altogether 9 elements. To get the next row of our product matrix, we have to start with the second row here, 2, 0. Now we're going to use 2, 0. I have to take 2 times the first, 2, 0 times the first column, 2, 0 times the second column, and 2, 0 times the third column. So when I do that, I'm going to get 2 times negative 1 plus 0 times 0, 2 times 4 plus 0 times 3 I love it when they have a 0 in there because it makes things easier. 2 times 6 plus 0 times 5. And we'll go through at the end and multiply and add. Okay, one more row. So now I'm going to use the last row of my first matrix, right here. -6, -3. And I have to multiply it by each column. So -6 times -1 times -3 times 0, or plus -3 times 0. -6 times 4 plus -3 times 3, and -6 times 6 plus -3 times 5. Okay, and then all you have to do is the math that goes with that now. That gives me -4 plus 0, so -4. 16 and 3 gives me 19. 24 and 5 gives me 29. Oops. And here I get -2 and 0, so -2. 8 and 0 is 8. 12 and 0 is 12. I'm just doing the math. +6 and 0 is 6. -24 and a -9 would give me a -33. This one gives me a -36 and a -15, so -51. This is the product that you get when you multiply those two matrices together. Okay? The math is not hard, it's just knowing what to do with your rows and your columns. Now, we're not going to actually multiply these, but I want to make sure you understand a couple things. So let's say I have matrix A, which is this. 2, 4, 4, -1, 6, -3, which right away you should look at that and say, okay, 2 by 3, so we know. And then matrix B is 1, -1, 0, 5, 2, 6. And you look at that one, 1, 2, 3, by 2, 3 by 2. And my question is, what if I want AB? That means you're going to multiply A by B. So A is a 2 by 3 times a 3 by 2. Can you do that? That's what you need to be able to answer. Can I do that? Yes, I can. And when I can do that because these are both 3's, and my resulting matrix is going to be a 2 by 2. But remember when I talked about how we could not use the commutative property? So if I want to multiply B by A, BA, that means I get a 3 by 2 times a 2 by 3. Does that one work? It does. It works because these are both 2's, but I get a 3 by 3. So you actually get a different answer. So be very, very careful when you're multiplying. Just because AB gives you a 2 by 2, that doesn't mean if you switch it around, it'll also give you a 2 by 2. Okay, we'll see you in class tomorrow.